Hi everybody, James Cross with SDS Automation, and today we're here with the ChannelBender SXP. We're going to do a short demonstration video just to show some of the more advanced features that this machine has that can really help to reduce your labor costs by automating tasks that were normally done manually, like drilling your drain holes, drilling your rivet holes, removing part of the flange at the overlapping seam on the letter. So what we're going to do is, it's a fairly simple letter we're running. The goal again is to show these features, not necessarily the capabilities of the bending capabilities of the machine. So we're going to run this capital letter A, the outside part, and also the inside part. And a couple of things to keep your eye on as this is being formed. On the back side of the letter, this is 3.5-inch 040, and the machine will be putting the flange on the letter. It will be putting the notches in the flange at the outside corners. And also at the seam overlap, you see these two 1/8-inch rivet holes on each side. The machine will create those. It will also create this slight offset break in the overlap, and what that allows for is the seam to be completely flush by tucking one side of that overlap down onto the other. And then the last thing to look at this part of the letter is right here. You see there's a notch cut out of that overlap, and that is the machine removing the flange on one side, which your fabricators are probably doing with snips or shears right now. And on the bottom side of the letter, the 1/4-inch drain holes are being punched by the machine. And just to demonstrate the adjustable height of that hole punch unit, we have one single hole centered on the right leg of the letter, and on the left leg we have two holes. So that hole punch can travel up and down, put holes anywhere in the wall of the letter, or even the flange. It can put 1/8-inch rivet holes in the flange if you need to rivet your back panels on. And then the machine will automatically move on to bending the inside part of that letter A. It will create the same 1/8-inch rivet holes and offset break at that overlap. So it will do one part and then automatically move on to the other without any additional input from the operator. So, whether your set of channel letters, whether you need to run one letter because something got damaged, the machine can do that. If you need to run an entire set of channel letters, your operator can set the toolpath for the entire job, and the machine will run one letter after the other until it's complete. And we have Kyle, our technical operations manager here, who's going to step into the frame and go through a couple of pointers on the software here and actually run the machine, set everything in motion. So anyway, welcome Kyle, and thank you for joining us.
All right, let's take a look here into our software that we have on all of our channel benders, our SDS Bender CAD software. Our software is able to open design files of different formats, whether it be Adobe Illustrator, a PDF, or in this case here, and most commonly, a DXF file. So as we can see, we've got our full file here. We're going to focus in on this A. And I do have the machine loaded right now with 3.5-inch 040. And we do have our material catalog or material selector here in our software. We can verify that we have that material selected. That will apply all the proper processing settings, as well as the machine function for this type of material with the flange. So let's go ahead and select that. So first thing we need to do here is choose where we want the seam on our letter. And in most cases, the outside of the letter, the seam is towards the top, so it's not visible when mounted. So I've got a point here that I'm going to use for my seam. And we're going to select toolpath draw here, and because I want my seam up here, I'm going to select that as my start point for my toolpath and my end point. Now you'll notice that I drew this toolpath was drawn in a counterclockwise direction. This will accomplish one thing for us, and that is how the offset is applied to this toolpath. This file here that I have open is the same file that's used at the router to cut the back panel out. Therefore, I need my return to be a little bit bigger than the back piece so we can fit that in there. So by drawing my toolpath in the counterclockwise direction is applying a positive offset to the return so that will fit around the back panel. So let's go ahead and set that. Here that brings us to our toolpath draw options where we can adjust the quantity, the type of seam that we want, whether it's our overlap seam or if it were maybe a butt joint, more commonly used for 063. But we have all those options here. I like what we've got, so I'm going to go ahead and apply this and move on to the next piece. Now let's go ahead and draw the toolpath for the inside. So again, toolpath draw, my seam here at the bottom, and in this case where my return needs to fit inside of this hole here, we're going to draw that toolpath in a clockwise direction. So again, the offset is applied properly. Got my options set here. Now I do want to add a couple drain holes to the outside of this letter A. So we have our hole selector here. First we're going to choose this one that's going to apply 2 holes at this location. And then let's apply just 1 on this other leg, just so we can see the versatility here in setting these up and using the punching unit. All right, so we've got our toolpath on our outside with drain holes. We've got the toolpath for the inside of the letter A. Utilizing our toolpath list view here, we can see a graphic list of all the toolpaths that are drawn within this file. In our case here, there's only 2. But we can individually select the pieces we want, or if I had a fair number of toolpaths, I could also use the Select All button here to select the whole set. I've got these 2 selected. I can see how much material is needed for those 2. So I can take a quick glance at my coil and make sure I've got enough there. Well, let's go ahead and run this. So as soon as I click the run button here, the machine's going to start processing these 2 pieces. So let's get going on that here. So we'll see each piece starts with a nice clean cut, and then we're removing that overlap seam there. And let me go ahead and open up the cabinet here. We can see a little bit more of what's going on. We've got our feeding unit here, moving the material. And now our punching unit, which is auto height adjusted, applying those punches at the heights indicated, whether it's for the rivet hole or the drain hole. Our flanging unit back here, creating the flange, and then our notching unit, notching the flange where needed. And now we're starting with the bending here. First bending that offset overlap. See those drain holes created there in the flange, or in the return, excuse me. All right, so there we have our outside there, and it's going to move on to making the inside piece here. Again, bending that overlap seam. All right. All right, so let's take a better look at a little closer up look at these two pieces here. We'll move into this side camera. So here we have our outside piece, again, with the rivet holes, and then our overlap seam here with our, our drain holes on the bottom, our rivet holes up top here. And I've got a rivet here, and we can see how well those line up. I can easily slide a rivet in there and pull it tight, but you'll see how that lines up beautifully. It's flush here on the front because we removed that, that flange there. And then we've got the same here for the insert. Comes together nicely, fits right in there. So there you have it, a brief overview of our ChannelBender SXP running a 3.5-inch flanged 040 return.